Good afternoon. I hope you enjoyed the lunch break and feel refreshed and ready for the remaining talks of today. This one's called Key to Success, Understanding Keyboard Shortcuts in Jetpack Compose. When Google introduced the Pixel tablet a couple of years ago, many of us were hoping for a productivity hub with a physical keyboard and a stylus in the box. Well, unfortunately, as you know, we got a loudspeaker instead, which I believe is a pity because many other vendors are embracing physical keys as productivity boosters. And this is what this talk is about. Take a look at Apple. They have been selling keyboards for various iPad models for quite a while now, and regardless if they really are magic or just keyboards after all, they are very popular among the iPad users, and that's because the users feel that these keyboards pretty much add to the productivity of the device. This mainly goes because Apple added a lot of features to iPadOS that use the keyboard for productivity stuff. And there's also a very thriving independent ecosystem of manufacturers that provides keyboard solutions for iPad models that are not blessed by Apple. So, for example, the one you're seeing on screen, this is a combination of a Bluetooth keyboard and a nice case for my iPad mini, and it really works cool. If we turn to other platforms, Chromebooks has embraced detachables since 2018, and when in 2020 the original Lenovo Duo was introduced, it became quite a success among the budget two-in-one devices. And the reason for this is that Chromebooks evolved to transition its UI seamlessly between tablet and desktop mode. And a lot of this we probably will be seeing in the desktop mode for Android, which whoever has a Pixel might have tried that out. At the moment, it still feels a little bit basic, but I hope that this will improve even further. And even now, connecting the Pixel to a huge screen and then having a mouse and a keyboard is quite nice, actually. If you haven't done so, give it a try. Speaking of the desktop, then obviously the desktop operating systems have been relying on physical keyboards basically from the beginning. With the rise of the graphical user interface, they combined the ease of use of the mouse, graphic path, with the speed of using a keyboard. Now, while this sounds great on paper, what does the speed of using a keyboard actually mean? That's where we come to key presses. So I would like to introduce you to a couple of terms. The first one being the shortcut. The shortcut executes a command much like you execute the command from a menu bar. So the important thing about a shortcut is that it must be discoverable through, for example, a menu or a tooltip. And this implies that the shortcut is an alternative way of executing that command. So there is always a primary one, which is selecting the menu item in the menu bar. There is another key combination that is very, very popular among Windows and Linux users, but not too common on Mac OS, and these things are called access keys. Active keys activate visible UI elements, and usually this is a combination of the alternate key, which is the option key on macOS, and a letter. For example, the Alt key and A here to discard a dialog. This key combination should be discoverable on the element itself, as you can see on the screenshot, for example, by underlining the letter in the word apply. So, not too much surprise here, it's an alternative way of clicking on a control. So what I said for the shortcuts applies here as well. So there always is a preferred or primary way of doing this. I mean, but for a button, it's pretty obvious. How other would you interact with a button than clicking on it? Anyway, there is a third group of key combinations which are called hotkeys. And hotkeys trigger global or system-wide actions. So you can think of them as shortcuts that work across applications, which means they are not tied to the focused app's UI. Unlike the previous ones, however, they are not discoverable easily, so there is no menu that would show you what you can do with Command Tab which means you need to learn this by heart. And these are the ones that I'm not going to cover in this talk. Anyway, now you may be thinking, yeah, this sounds cool, but this talk is about how to do this in Jetpack Compose, so get started with it at your service. So I will be showcasing you this with a sampler app that's called a keyboard shortcut demo. You can scan the QR code to get the link to the corresponding GitHub repository. In this repository, you will also find the PDF version of the slides. And if you didn't have your smartphone ready now, I will be showing you the QR code again at the end of this talk. Now, what's this app about? It's roughly about two areas, so two groups. We will start with the shortcuts, and the second one being the access keys. And this is the one I'm particularly proud of, because access keys is something that just hasn't been present in Compose so far. You will see shortly what I mean by that. But let's start with the shortcut. So as you all know, there is no traditional menu bar on Android, which makes sense because menu bars work best if there is a mouse pointer and a corresponding input device, which usually isn't present on a mobile phone. But we do have a similar concept, which is called the app bar. In the early days of Android, we didn't even have the action bar, but we had a dedicated menu button which could open a so-called options menu. And in that days, later Android versions, we got the idea of the action bar. The action bar was introduced first with Honeycomb, which, as you probably know, was a tablet-only operating system. So the action bar then made its way to become an app bar. So what is an app bar? It contains top-level commands, which are called action items. And much like menu items, they can have a label, an icon, and a tooltip. Why am I emphasizing this? Well, because we need something to highlight which key combinations we want to press. So we at least need to have a tooltip or something like that. Action items can also be put in a menu. And what's interesting about this, while the Compose implementation of an app bar has no built-in support for keyboard shortcuts, the older and no longer fancy Android View-based implementation does have. I will be returning to this shortly, just because I couldn't refrain from peeking into Google Code. But let's start with activity-level shortcut support. So there are two important methods or functions that you should be aware of. It's the onProvide keyboard shortcut, which informs the system about so-called keyboard shortcut groups. So now, what is a keyboard shortcut group? It basically groups a list of keyboard shortcuts under a common headline or label. And the second function, onKeyShortcut, is called by the system when a registered keyboard shortcut has been invoked. Now, this is the Google code I was referring to. Sorry, I need to stay close to the mic. So these are both functions taken from the activity level. So there is the onProvide keyboard shortcut. So what this code does is, just to be reminiscent of the past, if there is a menu and if the menu item does have shortcuts, then they will be added to the system. This is in a way interesting because something similar we will need to do for our Compose apps anyway. And then there's the second function, which is invoked when one of these keyboard shortcuts has been pressed. And what's interesting here is, as you can see, it delegates the whole functionality to the action bar. This is why this probably does not work on Compose, because we usually have our Compose activities without a system-provided action bar. Anyway. So I promised to explain how to do this with Compose, so let's take a look at my sample app. We start with a list of global shortcuts. As you can see here, I'm using a custom class I've written. It's called the keyboard shortcut class. So it takes a couple of parameters, the first one being the label, which you can compare to the menu item label. Then we define the key using the key class, which is reusable across Compose on different platforms. But we also need to have that same information again as a string. Why this is the case will become clear later, and I would wish that this was not necessary, but anyway. And then there is a list of Boolean parameters which basically define which modifier keys need to be pressed in combination with that letter to activate the shortcut. Now I'm passing this list of global shortcuts to my root composable. We will turn to that later. And I'm also using it to create yet another list, and this list is the one that's going to present it to the activity. That's why I called this variable, list keyboard shortcut info, because that's how the corresponding Android class is named. And so we basically need to do a mapping here. So again, why do I need to do this? We want the app to run on Android, on iOS, and on the desktop, which means that we must not use classes that are available on Android only. That's why I need to define classes that can be used everywhere. And on the platform or operating system level, I obviously need to convert these. Now, let's continue. The onProvide keyboard shortcut function, like I explained earlier, is called by the system to obtain the list of keyboard shortcuts that are to be provided by our app. So what we are doing here is we are iterating over our list of keyboard shortcuts and put it into this nicely group with a label and the list of keyboard shortcuts, and pass it to a data structure that has been given to us by the system. Now you may be wondering, well, how does this look at runtime? So this is how the keyboard shortcut that has been defined here will look if we run the app. So this is a system-provided dialog that shows the list of keyboard shortcuts that have been provided by applications or by the system. If you think back when I was showing the code that works on view-based menus, these would show here as well, of course. On the activity, there is also a function we can invoke to summon this dialog, which is pretty nice. And we can do this from our Compose code, and to be able to achieve this, I just pass a method reference to my root composable to be called when a button is clicked. All right, now there is one thing left to be done, so react on key presses. So this is what we are looking at here. So when we receive a key press, this function is called, and what we need to do then is iterate over my list of global keyboard shortcuts and check the key event that has been passed to us and try to find a match. Now there is one thing I need to show you. So I have written an extension function on this class here because I need to map the Android versions of the modifier keys to the Booleans that I have in my custom class. So not particularly important, but just to make the picture complete. So if we do not find a match, meaning if that keyboard shortcut was not from us, besides that the function shouldn't be called at all, we would be returning to the super implementation, which would mean if we had a view-based menu, it would then have a chance to react upon it. The part that is more important, of course, is what happens if that was a keyboard shortcut that was registered by us. This case, we return true, which signals the system, yes, that's my keyboard shortcut. I have reacted upon it. Do not propagate this event any further. And the second thing we are doing is I'm invoking a function that's called trigger action, and that function is part of my keyboard shortcut class, which inevitably means that I now need to show you the implementation of this class, which is pretty simple one. As you can see, we have the list of parameters. So again, we have the label. We have two ways of representing the letter that should be pressed. And I also mentioned a set of Boolean parameters which define which modifier key needs to be pressed in combination with that letter. The interesting part is this one. So we are having a channel which is conflated, which means that it holds one item at a time. And whenever this trigger action function is called, we try to send a value to this channel. Now, this in its own is not particularly exciting. What gets exciting is if someone consumes a flow that listens to this channel. So that's what this flow property is about. So whoever collects the values from this flow will get informed whenever this key combination has been pressed. And this is the missing link. This is the thing we need to connect the activity level shortcuts to our composable world. Before I come to the next slide, there is something I need to show you. You probably have been frowning about this piece of code. This looks really shitty, doesn't it? Though what we need to do here is we need to find a visual representation of the key combination. And the sad thing about it is that, up to my knowledge, there is no publicly available method that allows me to do this, neither on Android nor on the Compose multi-platform side of things. So for now, we need to do it like this, which is a shame because in real world, this code would be a little more, well, not complicated. There need to be some more things to be considered. For example, on Chromos, the meta key is so-called search key, and it has a dedicated symbol, which means that if that code was to run on Chromos and we really wanted to be platform, adhere to platform principles, we would need to show that special symbol. I left that out for brevity, but keep in mind that this code might need some polish if you want to use it in a production app, or beg Google and JetBrains to just add it. Anyway, again, I think this looks pretty cool, but the interesting question is, now that we know there is a flow we can consume, what happens next? To understand the code I will be showing afterwards, take a look at this video. So what you can see here is what happens when either the shortcut is pressed or the item is selected from the drop-down menu. We see a, where's the animation not running? Anyway, we should be seeing a snack bar. So that's the magic. When the key combination is pressed or when the menu item is clicked, we see a snack bar. And the corresponding code is like this. So we have a simple string state which contains a snack bar message, which initially is empty. We pass that snack bar message to another composable, which is just responsible for showing the snack bar if the message is not empty. If the snack bar is dismissed, we need a means to clear the text again. And the thing that really is the glue to everything I've shown you so far is how do we listen to the flow. So what we are doing here is we are just iterating over my list of keyboard shortcuts. For each of the keyboard shortcuts, we launch a coroutine, and inside this coroutine, we collect the latest version of the corresponding flow. And if there is a new value collected, and here in my implementation, I just set the snack bar message. In your implementations, you would obviously do different things based on the keyboard shortcut, but the mechanics remain the same. So every keyboard shortcut class would listen to that flow, and when something gets collected there, it means that the corresponding shortcut has been pressed, so you can do whatever you want with regards to that keyboard shortcut. Okay, so the next thing we need to do is to enhance the visual appearance of the drop-down menu. So as you can see, we want to educate the user by showing the keyboard shortcut that can be pressed to activate that function. Like I said, this is easy with view-based menus, but Compose drop-down menus do not have this out of the box. So let's see how we implement this. The first thing, we use an ordinary drop-down menu. That's the composable that comes out of the box. And for each of the keyboard shortcuts, we create a drop-down menu item with, how did I call it, with shortcut. This is a custom implementation, of course. It receives the text, it receives the shortcut, and it receives the on-click callback, which does two things. It closes the menu. This is something we need to always do when we have drop-down menus. And then, as you can see, we just invoke the trigger action. So here now you see the whole thing I invented full circle. So if you want to execute what is connected to that keyboard shortcut, just invoke the trigger action, and anyone who collects the corresponding flow can react upon it. Apple would probably say it's magic. Anyway, so again, remember that nasty bit of code I just showed you, so we need to somehow get a visual representation of our key combination. That's the small print in black. So that's the source code that in an ideal world would have been provided by either Google or JetBrains. So for now, we have to live with my poor man's implementation. Anyway, let's continue with my code. So we now have the drop-down menu item with shortcut. How do we implement this? Again, it's using something that comes out of the box with Compose. So we just have a drop-down menu item. And the only difference is that we pass not a humble text composable, but instead we again pass a custom composable, which I called shortcut text. The implementation of this is rather straightforward. We have a row, which means we put things beside each other. This row has either one or two items. One item if there is no shortcut provided, then it's just the text. If we provided a shortcut, then we add a second text, which represents the visual representation of the shortcut. Style it slightly, for example, here by changing the opacity, we make it appear a little lighter. And the thing I want to highlight, even though it has nothing to do with keyboard shortcuts, we baseline align the two texts, which is something that is not done most of the time. So if you see any samples related to a row, you usually see these things vertically centered, which from a UX perspective is a nightmare. Any composable that has the concept of a baseline should be baseline aligned to make that thing visually appealing. So please, no vertical center in rows. Awesome. Sorry, I think so. How does it work on other platforms? Let's turn to iOS. And in advance, I am apologizing. So I need to turn to the monitor a little more because I honestly can't remember the class names I need to use. So I need to take a look at them, so forgive me. So, but as you can see on the iPad, we have a global menu bar, just like we have on macOS. And the menu bar gets an additional sub-menu in the help menu, which will list any registered keyboard shortcut. So in a way, this is similar to that Android-provided system model bottom sheet that lists the keyboard shortcuts. And I believe being able to pass our shortcuts there is pretty cool. So let's see how we implement this. Let's start with the easy stuff. Let's start with the compose content, just to give you an understanding what the composables are. So we have the main screen. That is, generally speaking, the whole screen, everything from the scaffold, including the composable content. There is a second composable. It's this one, which is, again, a poor man's implementation of that nice system-level Android dialog. So we don't have this concept, for example, on Compose Desktop. So I wanted to have a minimal implementation that can at least show my custom items, keyboard shortcut items. And I'm also using this on iPad. So when a button in that app is clicked, that we see this modal bottom sheet, which lists the keyboard shortcuts. And now it's getting interesting. So again, I apologize that I need to bend down a little. So given we have this compose content, we pass it to a compose UI view controller. This is the code that you can see here, which in turn is passed to keyboard shortcut view controller, I apologize, along with a list of shortcuts, which in turn is returned by main view controller, which is called by Swift code. I didn't try to learn that by heart. Let's just continue with the next slide. So this keyboard shortcut view controller extends UI view controller. And given the class names, we are heavily deep inside iOS, where probably no one of us wants to be. But anyway, I did it just for the sake of this talk. So given it's a UI view controller, we can or sort of have to override a couple of functions or methods. So the first one being this onViewDidLoad. This is where we will be hooking the keyboard shortcuts to the system. So for each of my keyboard shortcuts, we need to create a UI key command, which is then registered using add_key_command. Now, spot this beautiful line. So this is how we make sure that the function below can be resolved when the keyboard is pressed. So I really like this. So getting a string representation and then registering this is beautiful. Anyway, the other two things that have a red, yellow circle just indicate that these things are needed to make things work. So we are building Swift view hierarchy, and we need to make sure that this hierarchy is set up properly. That's what the first function does. And the second one, this first responder thingy, is required to tell the system, yes, we want to get keyboard shortcuts. So we need to return true here, because otherwise the system would not send the shortcuts to us. So this is the important stuff. And the final thing is, again, you probably have guessed it, at some point in time we need to check if a pressed keyboard matches one in our list of keyboard shortcuts. If there is a match, we will be invoking my trigger action. This is done by this code. The only thing I would like to highlight here, for reasons of simplicity and for not having to use another screen page, I'm not checking the modifier keys here. So the code at the bottom of this listing does not check for modifier keys. This is something we would need to add to make it bulletproof. Anyway, for the desktop, it's getting way more easy, I promise. So desktop means we are tackling Windows, Linux, and Mac OS. So here the code is pretty straightforward. So again, we are having our main screen. We are having that second composable that would be showing the model bottom sheet. And the desktop specific part is just this one. So we are creating a menu bar, which has precisely one menu item. And this menu item will contain each and every of my defined keyboard shortcuts. So I'm iterating over the list, invoking that item composable, which receives some information, the label and things like that. And again, the on-click callback, which, not too much surprise, will invoke trigger action. Bam. And that's been the first part. Am I in time? Yeah. The next part is access keys. So, like I said, I'm a little bit proud of this, because this is something that hasn't been present in Compose so far. Access keys means we can interact with UI elements by pressing a certain key combination. Here we have a switch combination with a label. If we press Alt-D, we will toggle the switch. And the same goes for the button. This is something that is very important on the desktop. Unfortunately, mobile has forgotten about this anyway. So we need to achieve two things: underline the key, and second, react to the key combination. This is the Compose code that shows the part of the UI you're seeing on the right-hand side. So switch with a text is really just a custom composable. That is a switch with a text, so nothing fancy here. And the button is just a button. What the two things have in common is this beautiful composable. So it's the text with underline jar. So what we need to achieve, remember that we want to have a text where one character is underlined. How do we do that? The first thing we need to remember is that we need to indicate which character should be underlined. I am doing this by prepending an open square bracket. So to find that out, we have a nice regular expression which looks for starting an open square bracket followed by either lowercase or uppercase letter. If no one is found, we append the string just the way we would. If, however, we find that combination, we have an annotated string that starts unstyled with a part that is left to the open square bracket. Then the second part is we show the letter and underline it, and we close by adding the remaining part of the text. And this nicely underlines exactly one character. Do I still have time? Yes, 10 minutes, I think so, right? Yeah. Okay, this has been the first part, so we now know how to underline characters. The second part would be reacting to the key presses. Before we come to this, let me take you on a short excursion. So if you take a look at this animation, here the tab key is pressed, which results in a nice animation, but besides that nice animation, we see the cursor moving because that's what the tab key does. How do we implement this? So we have a humble text field, and the interesting part here is the modifier. So we have a on-key event modifier, and what we are doing here is we are checking if the tab key has pressed, or to be more precisely, if the tab key has been released. If this is the case, then we start our animation and return true. Otherwise, we return false. The return value signals either if we have consumed the event, meaning true, or if we return false, this means someone else may take this event and do whatever it pleases. So when onKey event is invoked, the text field's default action for that keystroke has already been executed. That's what you see with pressing the tab key, so the tab movement is visible. To receive key events, the event must be focusable. This is something you didn't see. This is something I need to tell you. And if the event has not been consumed, indicated by returning false, the parent element will be asked to handle it. That's what I already told you. Now the problem is, yeah, but what do we do if we want to consume the event before that default action has taken place? That's when onPreviewKey event comes into play, so it intercepts key events before the component's default action is executed. Events travel down the tree, which means from parent to child, towards the currently focused component, allowing a parent to intercept events before its children. That's important. Unlike onKey event, a composable using onPreviewKey event does not need to be focusable itself, as it can intercept events traveling down towards a focused child within its subtree. This is important because we will need this further down the road. And the last one is very, very important. A component within its subtree must have focus. Please try to keep this in mind. I will return to this shortly. Thank you. So, this is the composable that makes use of the key presses. The first thing to keep in mind is I defined a custom modifier, which I called keyboard shortcuts. As you can see here, it gets a list of pairs, each pair representing the key to be pressed in combination with the Alt key. That's why we just need the key. And the second thing being the action that should be invoked if that key press is happen. And then remember that I was very much emphasizing on focus, so this is why we need to get a focus requester and why we need to request focus for some of the composables. So here's something you should keep in mind. Intercept key events as early, which means as close to the root as possible. That's why I'm attaching my modifier to the scaffold, which seem pretty high. And the second one, have your component root request focus for best results. So this is nothing that Google or JetBrains tells us. This is just findings that I got while writing and testing this app. Now let's take a look at the implementations of my custom modifier. As you can see, for iOS and the desktop, it's pretty much the same, besides this one. So why does the code that computes the return value differ for iOS and for the desktop? For the desktop, it's enough if the Alt key is still pressed. We indicate to the system we have consumed the event, whereas on iOS we need to have this one. So why is this? onPreviewKey event and onKey event report physical key states, that is either key down or key up. There is no high-level key typed event, which means we sort of need to combine this on our own. And the situation is that Compose relies on the native event handling on each operating system, and the problem is they produce different event sequences. And that's why we have different implementations on iOS and the desktop. And there's something even worse. On iOS, returning true may not always stop an event from propagating. Now take a look at this video and you will immediately see what I mean. So I'm pressing Alt-D to toggle light mode, dark mode, and in the text field we see this unwanted characters. This doesn't happen on Android, and it also doesn't happen on the desktop, and that's because of this thing I mentioned on the previous slide. So iOS just wants to handle Alt-D and some other keys differently. Unfortunately, we need to take care of this situation. So what is an easy solution is just to make sure that if you have a text field, that these unwanted characters get filtered out. So this is not needed on desktop and on Android, but this makes the iOS implementation bulletproof. So what's left to be done is the Android implementation. So if you compare it to the desktop, it more or less is the same, besides that I'm using another modifier. And the reason for doing this is that there is our beloved Gboard, which intercepts quite a lot of keystrokes. For example, Alt-D will start dictation mode. So Gboard would kick in and my Alt-D would not be delivered to my app, but this modifier here makes sure that we get that key press. So that's why this nicely lengthy name is pretty self-explanatory. Right, there is one more thing I need to tell you. Remember that I have been heavily emphasizing that some component needs to have focus, and unfortunately, depending on the platform, this results in global events not being delivered. So to put it another way, if a composable has focus, then that activity level keyboard shortcut presses may not be delivered, which would be a pity, of course. Therefore, we just need to make sure that if we get these keyboard shortcuts, which we are not supposed to get, we just handle them on our own. So I'm having another on preview key event modifier, which iterates over my list of keyboard shortcuts, and if we find a match, we just invoke trigger action and are done anyway. That's been amazing, right? I really think. There's one more thing I would like to show you. Since this is an Android conference and since I'm an Android GDE, I would like to close with something Android special, and this is how can we detect if a physical keyboard is present. Oh, you probably have guessed this. This invokes reacting to configuration changes, and it's a pretty simple one. So we have a flow which we initialize to some value. Then we have a function that checks the configuration if a physical keyboard is connected or available or not, which sets the flow value accordingly. And we have two places where we invoke this function. This is inside onCreate, which means when the activity is created, then we make sure that the flow has the right value. And the second one being overriding the onConfiguration change function, which means that if a configuration change occurs, meaning keyboard is connected or disconnected, that code will be executed and the flow being updated accordingly. To make this happen, we need to configure the configuration change on an activity level, and this way we can easily decide in our composable what we want to do if a physical keyboard is connected or not. That's it. Some key takeaways. Shortcuts are essential for expert users and fast-paced interaction. Physical keyboards are becoming more common on Android, as we've seen Chromos and hopefully the desktop mode. And something I haven't mentioned yet, a few UI elements have built-in keyboard shortcut support. So text field and basic text field know about cut, copy, and paste and the corresponding keyboard shortcuts. And there are also some keyboard shortcuts which allow you to modify the selection inside this text field, which is pretty cool. Unfortunately, there are also a few challenges ahead. Like I already said, today's Compose APIs just cover basic shortcut requirements, so there is no reliable key type event, which I feel is something pretty severe. And the even more severe one is there is no easy way to get human readable text for key combinations. This is something that, no, anyway. I hope you enjoyed listening to this talk. Feel free to scan the QR code to get the link to the GitHub repository. It contains the source code and the slides in PDF. I hope you enjoyed the talk. Thanks for listening, and if you have questions, I'll be around until the end of the conference, so feel free to reach out. Thanks again.